It's the same thing sometimes. Be quiet.
All right, here we go. All right, so you guys, did we finish 16 in class on Friday? All right, so now we're gonna kick off with number 17. It's about how fast sound travels through water, which I guess sound actually it's kind of confusing, but it actually sounds it moves really quickly through solids. Anyway, this is how sound travels through water. So we'll start with a table. It says make a table. We're gonna put values for the time here and values for the distance here. So this is our equation. The distance sound travels equals 1.6 times the amount of time that has gone by. So you're gonna plug in 0, 1, 2, 3, and then you're gonna make a graph. So we'll do 1.6 times 0, 1.6 times 1, 1.6 times 2, 1.6 times 3. Hey, I think I'm even gonna do 4. Make sure you have a calculator. You're gonna want a calculator for Wednesday, and I don't have enough for the whole class. Like I only have like 4 anymore, I think. So bring your calculators. Tell me. Let me don't come back. Okay. Do your math. Everybody needs to do their math. Everybody do your math. I was not talking to you. I'm talking to the class, as is my job. So, if a problem asks you to make a table, this is a great place to start. Make a list 0 through 3, 0 through 4, and plug in. So, this is a lot like y equals 1.6 times x. And I put the t as the x because time is often like an x component of an ordered pair. It's an independent variable. The amount of time depends on the distance the sound goes depends on how much time has gone by. All right, so our first ordered pair would be 0, 0. And then 1, comma, 1.6. 2, comma, 3.2. So I'm going to graph mine over here. You guys, there's a lot of graphing in this assignment. You can just draw a quick graph on your notebook paper. This axis is the amount of time that's gone by, and this one would be the distance. There we go. So, letter A, make a table, values, and graph. Done. Letter B, use the graph. Use the graph to make a prediction. So make a prediction about 7 seconds. So that means your graph kind of has to be precise and kind of long. We can use mine since I got my other nice graph paper up here, this grid. So it says predict 7 seconds. We already calculated 1, 2, 3, and 4. 5, 6, 7 would be right here. So I'm gonna go up from 7, and that's my prediction. After 7 seconds, I predict it would be about 11 kilometers away. So in a nice sentence, I would say the graph shows after 7 seconds, looks like a little 5. The sound travels 11 kilometers. And I know you guys have seen those science videos where people are tracking whales. That whale sound travels through, really far. Their little calculators on the ship tells them where to go and how far that whale is. Track it. Right. Okay, so that's 11 through 17. We're skipping now all the way to number 27. So we're skipping, I think, a whole section of that review in the book and going to section 3-3. So we're jumping all the way to 27. Quiz, you were here Friday. Oh, you weren't? Okay. I do encourage you to watch the video from class Friday. It's on Schoology. The reason for that is there's a test Wednesday. And on Friday, I did I explained the topics and I did one example from each topic. So we're still doing the assignment listed. Chapter 3. It's a chapter 3 test. So there's 4 main topics. X and Y intercepts where you plug in zeros. And then this one, slope. So you only miss 3 of you for one topic. The second topic is rate of change in slope. So this one is slope. Find the rate of change. When the problem says rate of change, you got to think of rise over run. Rate of change. Rise over run. So you can just look at the picture here and count how far up and over it goes. Count from this point to this point, how far you're rising and how far you're running. Alright, I'm going to count. Up 9. Over. Over 3. So anytime you're asked about rate of change, slope, rise over run, you want to make that fraction simplest form. So divide the top and bottom and make this 3 over 1. 9 over 3 is the same as 3 over run. 3 over 1. There's something kind of interesting about number 28. The y values aren't changing. The y values are not changing. So you could do slope formula. you could do slope formula with these first two ordered pairs, or you can understand it. So to help you understand it, I'm going to draw a quick graph. I got a point at -2, -3, 0, -3, 4, -3. So this line, the y values aren't changing. How would you describe this line, Sean? I just plotted these points, and this is what it looks like. Just describe it. The green line. It's horizontal. It's a flat line. You could say here that there is no rise, right? If you're thinking of rise over run, if the y values don't change, it's not ever going up, it's not ever going down. There's no rise, there's no run. This is a zero slope. Alright, flat lines, there's no hill, just like Florida. Like skateboarding in Florida, there's no hill, there's no change in altitude, the y doesn't change. Zero slope. Alright, you guys, I'm going to give you a moment to do the slope formula here on 29 and 30. You guys try to do the subtraction, see if you're getting them right. Subtract the y's. Change in vertical over change in horizontal. Subtract the y's over subtract the x's. What's the better question? No, not right now. I made it home. Well, you remember this slope formula? Did you write it down? Okay. So we're on this problem right here. Do you want to open your book up so you can see it in front of you? Page 204. It's up to you. Are you guys looking at the book in front of you, or are you just looking at the screen? Mostly just the screen.
Oh, what page number?
So we're on this problem here, number 29. It says the only directions say find the slope. So when the directions say find the slope, you gotta have this memorized. So this is the first point, so we'll label it x1, y1, and this is the second point, x2, y2. Go ahead and do the formula. Subtract the y's over subtract the x's. I got one silent. Kenzie? Yeah, I do. Let me do. You need it right this second? Let me do these two, and then I'll get your Band-Aid. So 2 minus 5 over 6 minus 0. -3 over 6. So I'm going to give you like half credit. I even would give you more than half credit if you got this far. For your slope, I just want your fractions in simplest form. So reduce the top and bottom by 3. And I got a -1 over 2 for full credit. Alright, try it again with these two ordered pairs. A little more difficult because these have negative signs in them.
Are you new?
Yeah, so we don't like zeros in denominators. -2 minus 4. -6 minus a -6. Every time we see minus a negative, you know, we made that addition. Yeah, so we have -6 over 0. So, this means there is no run. This line is rising, 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 and never running. So this is like a cliff. This is an undefined line. There's no ground at all. It's undefined, the ground doesn't exist. When zeros in the denominator, you call it undefined. Correct. Alright. Another word problem. This one's about photos. So this really happened. The price to print photos decreased a lot. So the average cost to print pictures decreased from 50 cents to 15 cents between the years of 2002 and 2009. So find the rate of change and then explain what it means. That means we want a full sentence answer. When it comes to word problems, time is usually, you could say time or years is usually the X value, and then price or cost is usually the Y value. Alright, so you don't have to make a graph, but I'm just going to give you a quick visual. If this is years here, I would call this 2000, 2005. Correct. And then over here, we're going to go by cents. 50 cents. So the reason this is in the same section as that graph in that formula is because in 2002, it was 50 cents. In 2009, it was 15 cents. This is a graph. You don't have to graph it. You don't have to graph it. But what they want to know is the slope from 2002 to 2009. So our first ordered pair would be in 2002, it was 50 cents. And our second ordered pair is in 2009, it was 15 cents. So find the rate of change. How did the price of photos decrease in that decade? Well, 7 years isn't quite a decade, but it costs about 7 cents today to print a photo. Between like 7 and 13, I'd say. For one picture. Like if you send your pictures to CVS, they'll print them for you. And say you want them to do 50, they'll do like 50, 10 cents each. $5. To actually have like the pictures from your phone printed. Price. So X is usually time and Y value is a cost or some other variable in the word problem. What you should know, what's going to help you, is to know that the years and the time, that usually goes in the X spot when you're thinking of rate of change and formulas. Anybody have a number yet?
Yeah.
What'd you get?
5 cents.
Well, what'd you get for the full 7 years?
Oh, like how much was it?
Yeah.
35 cents.
Good. So this is our x1, y1, x2, y2. Do your formula. So it's 15.15 minus 0.50, 2009 minus 2002. So it's negative 0.35 over 7. And since it's already a decimal, you have full permission. You don't have to leave this as a fraction. Divide it out. Divide it out. What's 0.35 divided by 7? It'll be negative 0.05 over 1. But what does this mean using a sentence? What does this mean with regards to the price of photos? Sean? Not quite, but I like how you're using the word each. Keep in mind that this is, we're talking about rate of change and how it's changing each year. So this is talking about how the price is changing. Benjamin, you try it. Every year, the price decreased 5 cents. And that's what it means. So that's the slope here. It's going down 5 cents every year. Down 5.5 over 1. 0.05 over 1. It's a rate of change. How is the price changing over time? All right, so let's just take a look and be really honest, right? I'm really hoping that all of you guys are able to do rise over run looking at the graph. I'm putting a question like this on your test. Count up and over. I'm hoping you guys can do it looking at a table. And I'm hoping that you guys can do the formula when you have 2 points, right? I'm hoping a lot of you put a good effort into the word problem. I really try to write the information as ordered pairs and do slope formula. All right, next one. So we're moving from rate of change to direct variation. We spent a week on direct variation, a week on rate of change, and now we have to remember all of these topics together at the same time. This says that we have to graph. We're going to make 3 graphs. So right now in your paper, let's just at the same time write out 3 coordinate planes. So just go ahead and do a quick X and Y. You can just do them like all side by side. We're going to graph all of these the same way.
Chill.
So let's just set it up. All 3 of these are ready to be graphed. Direct variation. This is just a setup. You're ready. You're ready. You ready? Nice. Okay. So the section's titled direct variation, and the directions just say graph. So you have to remember, this is the formula for direct variation. This has to be memorized. All direct variations start in the origin. They all go through 0, 0. Not every graph on your test goes through 0, 0. Just these ones. These ones start at 0, 0. When the equations look like this. So you always start at that origin 0, 0, and then you move rise over run. And the rise over run is the value in for k. So we can start all of these right here. Now 32 just says y equals x. There's no number. What number is in front of that x? There's an invisible 1 there. I like to write it myself. Since there's an invisible 1, the movement is up 1 over 1. Up 1 over 1. Up 1 over 1. And the best graphs are able to go right, and then you're able to match the pattern the other way. And go left and down. So all three of these are starting right in the center and doing rise over run. Was what? Year rise, year run. Yeah, you keep going. Yeah. Try to go to the left. Rise over run.
So what if we take algebra
2 and 3.
You will take algebra 2 as a junior.
2? What about
After geometry, you take algebra 2.
geometry?
Geometry's next year. And then algebra 2. And algebra 2, you'll graph all these different shapes.
Ew, I hate that.
Algebra 1 wants to do straight lines. Algebra 2, you get to make line. Okay, perfect. So we're going to start here at 0, 0. Up 4 over 3 is just a little steeper than the first one we did. And then follow the pattern to the left. Down and over. There's 33. Yeah, you need to keep it open so you're checking out questions. So this is the only one that has a negative value. So instead of calling this one rise over run, I like to call it fall over run. Because it's negative, I'm going to go down 2 and over 1. So I'm still starting at 0, 0. And I'm going down 2 over 1. And then hopefully you can follow, you can match that pattern also to the left. So you should have a visual check. If the number's negative in the equation, the line should be going downhill. Uphill, uphill, downhill. If you have a negative rate of change, your line goes down. If it's a positive number, your line goes up. That should be like a little check that you do.
Yeah, so if it's this way, it's down.
No, you want to picture yourself like you read from left to right. You want to picture yourself walking this way, like you read a book. And here you're walking uphill in a positive slope. Uphill, positive slope. But I'm reading left to right here, and I'm sliding downhill.
So when it's this way, then it's always down.
Yeah.
Yeah.
All right, really good. Let's do 35. You guys are doing really well. 35 is the furthest I got all day. So let's keep going. It's good. We're working at a quicker rate of change than you're looking
At
at.
a high, sophisticated pace.
Are you ready for 35? You ready? Alright. 35 says, suppose y varies directly as x. The test won't tell you this, but as soon as you read that, you write this down. You read the words, and you have to have this memorized. Just like you have to have slope formula memorized, you have to have this memorized. There's quite a bit you have to memorize for this chapter. This is a two-part problem. All those numbers. This is a two-part problem. It says write the direct variation equation, then solve. So part one, write the equation. And what I mean by that is that you have to find K. K is the important number. It's the rate of change, it's the rise over run. So we have to find K. So we'll plug in the Y value here and the X value here. Ignore the last number. It's not important for part one. So this is 15 equals K times 2. Plug in your Y, plug in your X, plug in your K. Put your line in. You're solving an equation. So the opposite of multiply is divide. I don't want a decimal. I want you leaving this kind of strange looking fraction. So our goal is to write our equation. Our equation is going to be y equals 15 over 2x. That is part one. The rise over run in this particular problem is up 15 over 2. All right, part two is to use the equation. So we use these first two numbers for part one. We ignored the 8. Now that we have an equation, we'll use the 8. It says find y when x is 8. So let's plug in. It'll be 15 over 2 times 8. You're welcome to use a calculator. 15 over 2 times 8. If you want to challenge yourself, 15 times 8, right? That's 8 times 10 and 8 times 5. So 80 and 40.
15 times what?
120. 8. And that's the answer to part two. Part one is the equation. Part two is showing that you know how to use the equation. Yeah, go ahead and divide it by 2. That's your answer. Good job.
Bro, get a bucket in your face.
Alright, 36, same thing. You got part 1. Write the equation. You guys go ahead and find K. Find K on 36. Plug in the first 2 values. Solve for K. Alright, so I'm gonna put -6 here, K here, 9 here. Put the line in, divide both sides by 9. And we have a more challenging problem here because we're gonna have this weird fraction. -6 over 9 is K. Thumbs up if you got -6 over 9. Nobody? 2, 3, 4, 5, 6, 7, 8, 9. Okay, good job. Alright, now if you want to continue the problem like this, you'll get almost all credits. But technically, 6 over 9 could be reduced. They both divide by 3. So our K value is -2 over 3. So our answer for part 1 is y equals -2 over 3x. You're solving for the rise over run. You got that? Nice. Good job. Now part 2. Part 2, use the equation. I did not even see it. Do you know how to do part 2, Brian? So I have this equation, y equals -2 over 3x. I have that equation. It says find x when y is -3. Okay, so put -3 in for y. And now solve for x. Kenzie, you know what to do? You do. You know how to get x off? By what? Yeah, multiply by the reciprocal. So sometimes when you have this fraction, you gotta flip it. Multiply both sides by the reciprocal. The reciprocal has a really cool way of canceling out fractions. And now we got -3 times -3 is 9 over 2 equals x. If you didn't reduce it, maybe you got 18 over 4. 18 over 4 would be really good too. Alright, one more chance to practice this. Well, then we'll do the word problem. So we're getting a good amount of word problems here. So guys, try it one more time. Try 37. It's actually a little easier than 36. Try it a third time. Yeah. chance to do your variation process. Find K, write the equation, find the other. Part 1, part 2. Alright, I'm seeing some really good things. Alright, 37. I'm going to say 4 equals K times negative 4. Who set that up? Quez, did you set it up? Yeah? Katrina, did you set it up? Did you get this far? What'd you get for K? Either one of you guys find K? I'll divide by negative 4. 4 divided by negative 4, negative 1. Negative 1 is K. So my equation is y equals negative 1x. And that's part 1. Part 1, write the equation. Part 2, use the equation. Find y when x is 7. Negative 1 times 7, negative 7. You have these exact problems on your test.
I have a question. Why do people put signs up everywhere? Basic signs.
There's vaping signs up.
They're talking about it's all fun and games until like depression, insomnia.
There must be funding right now for. Is it like a?
Ain't no
Is it made by Palmetto High School? Or is it? It's made by an organization.
No, a teacher cut them up and stuck them everywhere.
Okay, then so you know the answer to this because the teacher wanted to put that up. You know the answer.
These kids slow. If they gonna do it, all that stuff is fun.
Okay. Anyway, back on track talking about mathematics. All right, number 38. Let's do this word problem. All right, 38. So this is actually calculating an hourly rate. So let's see how much this person makes per hour. And you guys let me know if you think that's a good hourly wage. Okay, it says that suppose you earned $127 for working 20 hours. Write an equation relating the earnings to the number of hours you worked. So it's still direct variation. I told you guys that hours usually X or Y? Hours is X or Y time. X or Y? X. So my ordered pair would be X equals 20 and my income would be 127. Alright, so you guys can use these two numbers to find the hourly earnings. How much are you making per hour? Go ahead, calculate. Find K. K will be how much you make per hour. So I'll put 127 here. Not sure the rate of change and put 20 here. Calvin, how do I find K at this point? Yes. And since we're talking about money, you can go ahead and get a decimal out. Go ahead and get a decimal out. Somebody needs to. 635 equals K. So our equation that'll tell us how much we earn is 635x. Is this a good hourly rate?
No.
No. This is now below minimum wage. When this textbook was published, this was not below. This was probably minimum wage 10 years ago. But now minimum wage is more like $8, right? Some people still make this much an hour. Who still makes this much an hour? No, McDonald's has a good hourly rate. No.
It's people not like actually.
No.
It's people who.
Graduate high school.
No, none of that. It's people who, do you know what, Tanisha? No. It's people who make tips. Okay, so everybody has to pay minimum wage. Everybody has to make minimum wage. However, if you're in the hospitality industry, they pay you a little bit lower than minimum wage, knowing that you make tips, everything you do. So if you make tips, maybe you still make this, but everybody else makes more than this per hour right now. All right. So how much would you earn for working 35 hours? And think about this, there was just a recent debate about raising minimum wage all the way up to 15. So that's a huge increase. You know, minimum wage. All right, 35 hours, how much did you earn? That's full time almost. 40 hours is the full time. All right, write a complete sentence. In 35 hours, you earn, and hopefully this is before tips. Hopefully you're bringing tips in too. So what they say, to make a good budget, they say that your mortgage or your rent, how much you have to pay every month for your living situation, it should be a quarter of your monthly income. So can you rent an apartment for $222?
Yes.
Can you
No.
rent an apartment for $222
In
a month?
Airbnb.
You cannot. So you'd have to have like probably 3 other roommates if this was your income.
You don't spend $100 in a dollar.
3 other roommates. All right, let's go on.
Honestly, but it's plus tax.
You have roommates?
I just bought a whole bunch of Reese's.
Honestly, yeah, Reese's got old.
I like the mini. Reese's cup and the pineapple.
What?
All right, 5 more problems done with arithmetic sequences.
Alright, let's be honest here. 5 times is better than 1.
If you got a crush on me, just say it.
No. It looks like a fire.
Say it.
Oh. Alright, so that was a full review on direct variation. This is a brand new section. This section is arithmetic sequences. Go ahead. If you know the formula, write it down.
Wait, please like scoot like 1 step to the left.
No, I'm not. Because they're going to be test questions.
I'm shaking. I need to stretch.
You know, Simon, you could actually do number 39. Could you tell me the pattern, how the numbers are changing?
I remember doing this. 5.
5. Now, can you find the next 3 terms?
26. 31. 36.
That's it. So, that moving test question, hopefully you did it. Alright, what's the pattern in 40?
Are you asking me?
I can ask you.
Minus 0.2.
Okay.
Huh? 0.8. 0.6. And 0.4.
Good job. Alright, guys, this is due at the start of class tomorrow, so finish the last few for homework.